Okay, chapter 3-5, fixed systems with 3 variables. Okay, an ordered triple is a point on a plane in space with the coordinates x, y, and z. So what we're doing today, previously I was making you find the point of intersection given 2 equations with 2 variables, x and y, meaning they were on the xy plane, meaning they were 2 lines in space that intersected at one exact point. There were 2 lines because it was 2D. Yes? Now we're in 3D. So whenever you add another variable, that means you add another axis. When you add another axis, that line turns into a plane. Do we understand that? Okay? So now I have these 3 sheets of paper, and we want to find out where these 3 sheets of paper intersect. Does that make sense? And that point of intersection is going to be called an ordered triple. Okay? An ordered triple means we've added another axis. Now, 2D looks like x and y. 3D, here's y, here's z, and now x is coming out at you. This was the xy plane. Now over here, I have the yz plane. You see that? The bottom, I have the xy plane. And then over here, I have the xz plane. You know what this is? It literally is taking a corner of a box. I know this sounds stupid, but it really is. It's taking the corner of a box and putting it on a 2D surface. Okay? Does everybody see that? Yes or no? Okay? Now, that is the background of what we're doing, and I'm going to quickly show you how to graph a point in 3D. So if I want to graph the point 3, 7, 8, ordered triple 3, 7, 8, how do I go about graphing that? Well, the x-axis now becomes the y-axis, and the y-axis becomes the z. But I don't have an x-axis anymore. So what we have to do is we have to draw the x-axis. So the x-axis starts from the origin and goes out at a diagonal. The slope of 1. Okay? Okay, so now, what we're going to do is we're going to go 3 units on the x-axis. So if I go 3 units on the x-axis, there's 1, 2, 3 units. Do we see the 3 units that I've gone on my x-axis? Okay, from that point, what would I normally do? If I graph the point 3, 7, I would do what? I would go up 7 units on the y-axis. Where's the y-axis now? It's horizontal. So I'm going to go from there, 1, 2, 3, 4, 5, 6, 7 points to the right on the y-axis. Do you see that? And now I have to add height to it. So I got to go up 8 units. So from there, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So this right here becomes the point 3, 7, 8. It really would, but I'm really not concerned about it. I just want you to understand where you could be at in space. All right? Where it would be at in space. And this is not in your textbook now for you to worry about, but I wanted to throw that out there as a good intro as to what 3 dimensions is, what it is when you graph it. Okay? Do we understand that, yes or no? Excellent. Because now today what we're doing is we're going to be adding another equation with another variable. Okay? Now, this is going to take up oodles and oodles and oodles of paper. Don't be afraid. And Patsy, this is probably going to take you a sheet of problems. Yeah.
Let's consider every step out.
And that's okay. And I want you to. Remember whenever I did 2 equations with 2 unknowns and I wrote down what I did, why I did it. Equation 1, equation 2, eliminating x, eliminating y. Do you remember me writing everything like that down? And I told you back then that I wanted you to write everything down because it was your roadmap, right? Okay? And whenever we're done 3 equations with 3 unknowns, you were going to need that roadmap. We're there. So if you did not have those habits then, you need to create those habits now. So the first thing we're going to do is we're going to do this by elimination. When you do this by elimination, The first thing we did is we looked at all the coefficients on the x's, remember? And we found the least common multiple. So if we look at all my coefficients on my x's, I have 2, 1, and 4. What's my least common multiple of my x's? 4. So this is going to be plus or minus 4. If you look at your y's, what's that one going to be? -1, 3, 1. It's going to be plus or minus 3. Excellent. And when you look at your z's, I have 1, -1, and 1. Plus or minus 1. Okay. Now, what did you just say, Kathy? We should get rid of z. Z is our best method. But here's what I want you to notice here. When you are working with more than 2 equations, you can never, ever, ever work with more than 2 at a time. Does everybody understand that? So if I have 4, or 5, or 6 equations, how many can I work with at a time? 2. What we did is we did a blanket least common multiple, right? We said if I look at all of them, my least common multiple is 4. In other words, no matter what 2 equations I choose, my least common multiple for whatever equations I choose is not going to be larger than what number? For my x's, it's not going to be larger than 4. For my y's, it's not going to be larger than 3. For my z's, it's not going to be larger than 1. Does that mean my least common multiple must be 4? No, because I could choose 2 equations where the 4 is not even in it, right? Do we all understand that? So now, we need to look at our equations and figure out, do we want to eliminate x, y, or z? Well, I have 2, 1, and 4 for my x's. That's not bad, because I can choose 2 and equation 1 and 3, which has the 2 and the 3. Let's repeat what I just said. I can choose equations 1 and 3 that have coefficients of 2 and 4 on them, and eliminate the x with plus or minus 4. Or I could use equations 1 and 2 and eliminate the 2's, right? Plus or minus 2's, eliminate the x's. The x's are not bad. But let's go to the y's. If you look at the y's, what do I like about the y's? The signs are opposite. That means less errors on my part. Do I like that? I do. So am I going to eliminate x or y so far? I'd probably choose to eliminate y before I'd eliminate x. But I haven't looked at my z's, have I? So if we look at our z's, you know what I like about my z's? They are changed also, but what's really cool is that, what's my coefficient on all of them? My coefficient's a 1. So which is better to eliminate, y or z's? Z's are best to eliminate. So you cannot change what you're eliminating halfway through your problem. What you choose at the very beginning is to eliminate z is what you are going to eliminate across the board. We are eliminating z. Write it big so that you know you're not changing it. Now, if I'm eliminating z, what 2 equations do I want to use? First and second are excellent. So I'm going to choose equation 1 and 2. 2x minus y plus z is equal to 4. And x plus 3y minus z is equal to 11. What do I do? Well, if you look at the z's, they are already plus or minus 1. So I just need to add straight down. 3x plus 2y, z's cancel out, is equal to 15. Sorry, it's equal to 15. Box that in, because whenever we box things in mathematics, what does that mean? We're coming back to it. So we box it in, so that means we're coming back to it. So now I'm going to come over here, and what equation have I not used yet? I have not used equation 3. I have to use it. So I'm going to use equation 3, and I'm going to write that down, which is going to be 4x plus y minus z is equal to 14. Now, I have what coefficient on my z currently on equation 3? I have a -1. Now, which equation would be best for me to reuse? Because I have to reuse one of them. So is it going to be best to reuse equation 1 or equation 2? Equation 1 is going to be best. So what we're going to do is we're going to reuse equation 1. So that's going to be 2x minus y plus z is equal to 4. And what's the beautiful concept here? These z's are already positive and negative 1. So if we just add straight down, 6x, y's cancel out, ooh, z's cancel out, is equal to 18. Do I like that? No. Why do I like that? My y disappeared. It's just 6x equals 18. Can I solve for x? I can't. So what should I do? Divide by 6 and x is equal to 3. Isn't our end result that we want is to find our ordered pair, our ordered triple, right? And now we have the x coordinate of that, correct? So now I plug in where? You go to your box and you plug in what you know. I know that x is 3. Since I know that x is 3, I plug and chug it in. 3 times 3 is 9. 9 plus 2y is equal to 15. Subtract the 9. 2y is equal to 6. Divide by 2. Y is equal to 3. I found x and I found y. How do I find z? Where? I don't have any z's in my box. So I go back to my very original problems. Yes? And I choose whichever problem makes me happy. The easiest one. So which one do you feel is the easiest one?
That second one.
They all look pretty much the same, but you want to choose the second one? I'm fine with that. So I'm going to choose, can someone please read that second one to me?
Y, oh, x, yeah, x plus 3y minus z equals 11.
Thank you. So that's one of my original 3 equations, and I plug in what I know. I plug in y and x. So 3 plus 3 times 3, 3 plus 9, 12 minus z is equal to 11. Now what? Subtract the 12. Negative z is equal to negative 1. The z is equal to positive 1. Yep. So my point of intersection, 3, 3, 1. I'm very proud.
Oh, that's okay.
Do we understand that? Do you understand why I was such a stickler on the whole concept of writing down your roadmaps and what you were doing? Okay? Now, the next thing is, be very consistent. Watch your signs. If you drop one sign, whole problem. If you drop one negative, your entire thing is going to be wrong. Do we all understand that? So let's do the next example here. Okay, what's the first thing we should do? We should find the least common multiple. Understand that this is the blanket least common multiple, right? So if I'm looking at my x's, I'm looking at my coefficients over here. So what's my coefficients? 1, 2, and negative 1. What's my least common multiple? It's going to be plus or minus 2, depending upon which equations you choose. It could be less, correct? Okay. So now, I'm going to go to my next one. My y's. What's my least common multiple of my y's? Plus or minus 2. Excellent. My z's. Look at my z's. My z's is going to be plus or minus 6. Again, that is a blanket one. It could be less. Now, what did you just say? You don't like the z's because it's too big. So immediately, you know what I'm doing? Bam, not doing that one. And then I'm going to look at my x's and my y's because they have the same one, correct? And I want to compare these two. So if I want to compare these two, I cheated, didn't I? If I want to compare those two, I'm going to say, what should I be looking for if I'm comparing? Are the signs opposite on either one? They're opposite on my x's and there's opposite on my y's. But which ones do I like better? I like the x's better because they already have a 1x and a negative 1x, right? Whereas over here, my y's, they do not. So guess what? I'm crossing off my y's, I'm going to eliminate x. Okay? So I'm writing down what I'm eliminating, nice and big on my paper because this is my roadmap, and I cannot change that halfway through. Do we all get that, yes or no? So now what two equations would you like to choose? 1 and 3. So that's going to be x plus y plus 2z is equal to 3. Negative x minus 2y plus z is equal to 10. I need a least common multiple of what here? Plus or minus 2 is my blanket, but is that going to be helpful here? No, I don't want the blanket LCM. I want as small LCM as I possibly can get here. They're already as small as they can get, and they're already opposites. So I'm simply going to add straight down. So negative y plus 3z is equal to 13. Box it in because why? We are coming back to that. Do we all understand that so far? What equation have I not used yet? I have not used my second equation. So I'm going to write that down. 2x plus y plus 3z is equal to 7. Now I want to eliminate what again? X. I'm not going to move halfway through this. Okay? So I need to eliminate my x. So I have to have a 2x here, so I need a negative 2x. So which equation should I reuse? I would say equation 3 is correct. Why equation 3? It's already negative. Since it's already negative, I am not forced to multiply by a negative and mess up distributing, correct? So now I need to look at my lovely little x's, and what's my least common multiple between those two? Plus or minus 2. So do I already have a 2x? And what do I need my bottom equation to turn into? So what am I going to multiply that bottom equation by? The 2. So I bring down my top equation because I'm not messing with it. If it's not broke, don't fix it. And I'm going to distribute the bottom one. So negative 2x plus 4y plus 2z is equal to 20. And now what do I do? Uh-oh. Yoder has a sign issue. What did I do? Did you see how I stepped back and I looked at what I did? And I totally wrote down the wrong sign here. Okay? That should be minus. That would have messed us up. Okay? So you have to be very careful. Step back a minute, and for me, whenever I'm on the board, it's hard for me to see. But as you guys are doing your problem, do a step, check. That is going to help conserve time later on. Okay? And now what do I do? I'm going to add straight down. The two x's cancel out. That's negative 3y plus 5z is equal to 27. Box it in. Now look at your two boxes. What do you got going on? Do they have the same variables? They're supposed to. If they don't, you've messed up. Line them on top of each other. And at this point, people, You can do elimination again, you can do substitution again, or you can do Kramer's d dx dy. In this case, you'd be doing d dy dz, right? Right? Instead of d dx dy. Why am I telling you to do d dy dz here? Because what are my letters? Y and Z, okay? Do I care what method you use from here? Nope. How many of you would like elimination? Show of hands.
I like elimination.
You like elimination?
It's easier.
Okay, how many of you like substitution? Substitution, you can do substitution here because I have a 1, don't I? How many of you like Kramer's rule, d dx dy? Okay, it does not matter. I can do it both ways. Would you like me to do it both ways? Okay, we're going to do it David's way for a minute because I'm with David. I like elimination. It's quick and easy. Okay? So now what do I do? I'm eliminating what? X or Y? I would be eliminating Y here. Okay? I want to eliminate Y here. So I need to have a plus or minus 3 going on, right? I already have a negative 3Y, so what do I need the top one to be? I need a positive, so I need to make that a negative 3. So if I do that, I'm going to get 3y minus 9z is equal to negative 39. I drop down my second equation. And what should I do? Just add it straight down. The y's cancel out. Negative 4z is equal to, what's negative 39 plus 27? Negative 12, right? Does everybody see that? Now what do I do? Divide. Z is equal to 3. So now that I found out what Z is, what can I do? Plug it into either one of your boxes. I'm going to cheat. And I'm going to go right up to this box, and I'm going to plug in what I know. Negative 3y plus 5 times z, which is 3, is equal to 27. What's 5 times 3? 15. Subtract the 15. Negative 3y is equal to 12. Divide by negative 3. Y is equal to negative 4. So now I got to plug them both in. And where am I going to plug both of those in at? I'm going to go back to the original problem and to one of them. And which one do you want to use? I'm going to use the top one just because it's the easiest. X plus y plus 2z is equal to 3. Was that equal to 3, guys?
Yeah.
And I plug in my z and my y. So x plus negative 4y, or x plus negative 4, 2 times 3. X plus 2, subtract the 2, x is equal to 1. So did we find y and z? So what's my POI? 1, negative 4, 3.
This one is
Okay. Now I'm going to quickly show you d, dy, and dz here. Or this stuff. No, sorry. This one, yes. Just so that you can see it, I do d being negative 1, negative 3, 3, 5. I do dy, which would be 13, 27, 3, 5. I do dz, which would be negative 1, negative 3, 13, 27. You see that? Negative 5 plus 9. And this is going to be 75 minus 81. And negative 27 minus positive 39. And then you could get all 3 points here. Do we all understand that, yes or no? Okay.
Yeah.
All right. It's going to be 9 through 19 on through 5. Okay, now, last problem I'm going to do for you. This is the one that looks the most difficult, but it is the easiest. Not yet. We're not out of here until when? 49, I was going to say, okay. All right, what do I do on this one? Oh, look at them. That's a tricky little one. Are they all lined up? No, they're not lined up. I know, I mean like that. I'm trying to make you watch. So 2x plus 3y minus 2z is equal to -1. X plus 5y, leave a space, is equal to 9. And then -5x plus 4z is equal to 4. You gotta line them up. I will do that, because I'm a tricky person sometimes. Right? So be very, very careful and make sure that you line them up. After you line them up, now I don't need that junk up top there. And I'm going to look for my least common multiple of my x's, 2, 1, and -5. It cannot be larger than 10. How about on my y's? 3, 5, and there's nothing. So plus or minus 15. And then -2, 0, and 4. Huh? Plus or minus 4. So looking at this right here, what would be the easiest thing to eliminate? Z's would be the easiest thing to eliminate. Okay? Which means I want equations to be in what? If I'm eliminating Z's, what's left over? If I'm eliminating Z's, what variables are left? X and Y. Do I have any equation with just X and Y already in it?
Yes.
I do. Boxed it in. Because you know what? Half my work's done. Right? So what two equations am I forced to use? I'm eliminating Z. So what two equations have I not touched? I haven't touched 1 and 3. So I'm going to choose equation 1 and 3, which is 2x plus 3y minus 2z is -1, and -5x plus 4z is equal to 4. And what am I eliminating? I'm eliminating z. So I need to look at my z's. So what's my least common multiple between -2 and 4? 4. So I need to have a positive 4 and a -4. Do I already have a positive 4? I do. And now I need a -4. So I'm going to multiply the top equation by what value to get a -4z? 2. So that's going to give me 4x plus 6y minus 4z is equal to -2. And I'm going to drop down my second equation. And what do? You add straight down. -x plus 6y, my z's cancel out, and they give me 2. What's boxed in? Equation 2 and my other one that I came up with. So I'm going to use the x plus the 5y is equal to 9, and the -x plus the 6y is equal to 2. And I'm going to either do elimination, substitution, or Kramer's rule to come up with my point of intersection. So you tell me, what method would be easiest? Elimination, because if you look at your x's, I have a positive 1 and I have a -1. So if I add them straight down, my x's cancel out and I have 11y is equal to 11. And what do? Divide by 11, so y is equal to 1. So now that I found y, what can I do? I can plug it in to one of my equations to get x. So negative x plus 6 times 1. Negative x plus 6 is equal to 2. Subtract the 6. Negative x is equal to negative 4. So x is equal to positive 4. So I found x, and I found y. Now what do I need to locate? I need to find z. Where can I find my z's? Now which equation would I want to use? Why would I choose the last equation? There's only 2 variables. So I'm going to choose the 4z minus 5x is equal to, can't see it, 4. And I'm going to plug in what I know, which is, I don't care about the y, do I? I care about the x. So 4z minus 5 times 4. 4z minus 20. Add the 20. And that gives me 4z is equal to 24. To give me z is equal to 6. So my POI is 4. My y value is 1. And my z is 6. Do we get it? Do you understand why now I wanted you to be very precise in writing everything that I needed you to write? Okay. Tonight for homework, you are going to use a lot of paper. You have problems 9 through 19 odd. I gave you 6 problems for homework. Okay? The 6 problems are going to take some time. But if they're going to take some time, I actually reduced it. I had 9 to 29 on. So I reduced it. So what I need you guys to do is you have to use elimination. But once you get it down to 2 equations with 2 unknowns, then you may use any method that you want. So just to elaborate on this, must use elimination until you get it to 2 equations with 2 unknowns. After that, you can use whatever you want. Okay? Any questions on what I just said?